Welcome to the Aerospace Advantage podcast. I'm your host, John Slick Baum. Here on the Aerospace Advantage podcast, we speak with leaders in the DoD, industry, and subject matter experts who explore the intersection between strategy, operational concepts, technology, and policy when it comes to air and space power. So if you like learning about aerospace power, you are in the right place. Now, to our regular listeners, thank you so much for coming back. And if it's your first time here, we really appreciate you joining us. Now, a lot of you may have seen this in the news, but the Mitchell Institute just set up a new center to focus on UAVs and autonomy studies. We're really proud of this because, let's face it, these are two key pieces of technology that are going to shape the future of air power. But they're also really complex. They'll also likely challenge a lot of our underlying assumptions, which means we can't treat them as if they're just another manned combat aircraft. Looking back at history, this is like the introduction of steel hull ships and internal propulsion replacing wooden sailing ships in the Navy at the turn of the century. You know, the emergence of what would become battleships, destroyers, cruisers, the types that largely make up a modern Navy, even today. Yeah, both eras of technology were fundamentally ships, but the new types really changed the entire way we were able to harness sea power. So I think next-gen UAVs and autonomy are really going to be similar. Their unique attributes will allow us to achieve mission effectiveness in an entirely different way, and we don't even understand its full capability right now. And this calls for thoughtful research and analysis, plus explaining what all this means to senior leaders here in DC and the public at large. So doing this is a tough task, but it's also super important and it's very exciting. So with that, we are proud to introduce the leader of our new center. She's got a tremendous bench of experience in DC, and she just wrapped up a really successful tour at RAND, Dr. Caitlin Lee. So Caitlin, first and foremost, thanks so much for signing up with Mitchell. We are so excited about this, and you are seriously going to up our game in this area, and we've been working in these spaces for a while, but your dedicated attention is really going to be a game changer. Would you mind saying a few brief words about the center?
Sure, Slick. The idea behind Mitchell's Center for UAV and Autonomy Studies, which we'll call MIUAS for short, is to inform and elevate the national security debate on UAVs and autonomy and kind of try to get past what people feel about these things to actually doing some research and analysis and providing some pragmatic operational insight into this area. And the goal here is, of course, to be objective as we do all this research. And so one of the most important ways I think we can do this is by bringing together top experts in the field to generate new ideas that will help leaders in DoD, Congress, industry, and the broader policy and budget community better understand the issues at play and make informed decisions. And so our guests today are going to be a really great addition and great way to kick that off. So on that note, though, instead of using this episode as sort of an infomercial for the new UAV Center, I really want to dive into the substance. And one of the most interesting and impactful technologies in play today that has the potential to really change the way we wage war is artificial intelligence. As you all know, we're in a world in which computers can increasingly solve problems as well as or better than we as humans can. And this ranges from diagnosing disease to translating languages and providing even like customer service. And for the world's militaries, AI is also poised to have a potentially revolutionary effect. On the flip side, we know that AI also has its weaknesses, and so we want to explore that a little bit as well. Just look at the algorithms for supply chain management during COVID. AI struggled when the assumptions changed, and war, always unpredictable, is very much the same way. And so add AI to the mix, and it can be a pretty explosive combination. So that gets to the crux of the issue. AI can really be a powerful tool for us in some areas, but we also have to be careful about when and how to apply it because it's not a universal silver bullet. So that's what I really want to explore with this great group here today, AI and its role in the operational military environment.
Thank you so much for that intro. And, back in 2019, Frank Kendall, before he was Secretary of the Air Force, gave a speech on the impact of technology on the future of warfare, and where he talked about lethal autonomy. Here's part of what he had to say.
The U.S. is still in the process of reacting to China's extensive military modernization program. But I believe that even more profound changes to warfare are on the horizon and approaching rapidly. The fundamental enabler of this change will be the technologies that contribute to lethal autonomy. And whoever gets this right first, again, is going to have a major operational advantage.
All right, Caitlin, what do you make of that given where we are today?
Yeah, sure, Slick. Well, fast forward to 2022, and you can see Secretary Kendall's pressing forward on this AI vector. Now, that doesn't mean we should get ready for a world of killer robots right away. Defense Department policy doesn't ban the development of lethal autonomous weapons, but there is this emerging consensus among defense leaders that for most missions, it makes the most sense to have human-machine teams. These teams consist of three essential elements: the human, the machine, and critically, that interaction between them. When they work together, they can often perform better than humans alone. Another advantage of this human-machine team approach is that the teams mitigate the risks of unchecked autonomy. Similar to those supply chain factors during COVID that I mentioned, they capitalize on the human strengths like creativity and contextualized problem solving. And so kind of recognizing that, Secretary Kendall has announced that two of his top priorities, the B-21 bomber program and the NGAD, or Next Generation Air Dominance Fighter, will use AI in this way, kind of partnering this manned aircraft with an unmanned one and have that AI brain sort of regulate the tasks between them. You'll see leaders talk about this technology, or the AI brain, as autonomous core systems. But bottom line, what it's supposed to do is team the unmanned aircraft with its unmanned counterparts. And Secretary Kendall's been pretty open about this vision.
I think that the technologies are coming together to allow us to do manned-unmanned teaming of a fighter, let's say, class aircraft with one or more uncrewed aircraft that accompany it. What that opens up to you is some really interesting tactical options that you don't have when you only have manned aircraft.
All right, Caitlin, walk us through this some more.
Yeah, so I think one of the key areas that needs a lot more investigation is this interaction between our operators and the engineers who design these human-machine teams. These two groups think a lot differently, and so it's really important to get everyone on the same page. Systems won't work if they don't fit how the operators think and act, but on the flip side, operators need to understand the technology is going to be different than their human wingman. So, this is just a really hard, complex relationship that needs to happen. We're talking about teaming up humans and machines in some of the most dangerous and unpredictable environments.
Yeah, I totally agree. So with that, let's bring on some experts who have thought about this a lot. On the operator side, we have Brigadier General Houston Cantwell, who commands the NATO Alliance Ground Surveillance Force. They're responsible for Global Hawk UAV operations. He's also got a lot of time flying the F-16 and MQ-9 Reapers. And I have to say, Houston, it's great to chat with you. And we go all the way back to before I even went to pilot training, when I was awaiting UPT lieutenant at Moody Air Force Base. So I've known you a long time. Congratulations on all of your success, and it's great to see you here today.
Hey, Slick, thanks so much for the opportunity. It is such a treat to see you after so many years and engage in this conversation, as well as with Caitlin, who I've crossed paths with many times. So thanks for the opportunity.
Now, representing the engineer side of the conversation, we have Dr. Anastacia McCallister. She's the Artificial Intelligence and Machine Learning Solutions Architect at General Atomics Aeronautical Systems. And as everyone knows, these folks are UAV pioneers, given their role with MQ-1 Predator, MQ-9 Reaper, and a lot more. So, Stacie, we really appreciate your time.
Thanks, Slick. Definitely happy to be here to chat with you guys today and kind of dive into some of these, very important but, very emerging topics.
Okay, so first and foremost, what is AI and how does it differ depending on whether it's being used in commercial or a military context?
Sure, that's a great question, Slick. So artificial intelligence is kind of a broad catch term for telling machines how to do things humans would normally do, right? We have a lot of different kind of specialty areas within AI, but just in general, it's teaching machines how to do things, whether that be, using data-driven methods, using human encoding methods. And, once you dive into it, the devil's always kind of in the details, right? When you kind of, look at the commercial side of things versus the military side of things. A lot of the AI we hear about today is more of the data-driven type of AI. And so what that means is the DoD in general, is a kind of siloed institution, right? For good reason in some areas. And so getting the data that you need to perform that data-driven AI to, kind of learn the rules that exist in those data sets to teach the machines to do them is a challenge, right? If you're, not Amazon or Google or, the e-commerce companies that can use their muscle to go through and label large data sets, to tell the difference between cats and dogs. We might not have the large data sets to scale on the DoD side that you can see in the commercial area just because of, various challenges that we see in the DoD space.
Wow, that's powerful stuff. And how do you think this will change how we apply air power? Will it cause our adversaries to respond differently?
Sure. So I think, one of the biggest intriguing factors of AI when it comes to, the military and, how how it's going to change how we fight, I think is just the time, right? So humans, we can react and we can, do things on a known time scale, right? It takes us a little bit to take in information. We only have such fast reaction time, and we can only take into consideration, a limited number of factors, right? When we look at that higher order reasoning, right? If you get beyond, one or two, key decision enablers, we can get overwhelmed, right? You reach that saturation point for cognitive load. But what artificial intelligence and machine learning specifically can allow us to do is we can take in more information quicker, right? And try and make decisions a little bit more automatically. But like we were mentioning before, that introduces a whole host of new issues that we need to start looking at.
Thanks, Stacie. You mentioned that for DoD, it may be harder to find and mine that large data set that you need to actually start identifying specific things that can help you develop better algorithms. How can DoD address that challenge? Does AI offer opportunities for organizations that struggle with mining large data sets?
Sure. So I think that's a very excellent question, right? Like I said, a lot of the stuff we see today is driven by very, very large data sets, but there are different tools that you can use in, the AI toolbox, if you will, to use those more limited data sets, whether that comes to, designing different algorithms, using, different types of data, generated data. But really, I think what it comes down to is I like to joke is, as a practitioner on the machine learning side, when I start talking with a potential customer, I like to joke, I do data therapy. I come in, I ask questions, I figure out, okay, what are you trying to do with AI, ML, machine learning, artificial intelligence, and, what does your data set look like, right? And we try and match the algorithms and the goals to, what the customer is trying to do. Because sometimes you need to work around some of those, intricacies in the data set. And that's why the back and forth between, the operational community and the practitioners is so important, is because we need to kind of understand the pitfalls that lie in that data sometimes.
General Cantwell, as someone on the front lines commanding and operating U.S. unmanned systems, what keeps you up at night as you consider our adversaries' efforts to develop AI?
Yeah, thanks, Slick. I mean, off the top of my head, I will tell you that I'm sure many of you have heard of the OODA loop. So the first thing I'd be most concerned about is the adversary getting a decision-making process that is faster than ours, okay? That's the thing I worry about most. But when I think about the adversary getting to that point, I really want to key off of something that Stacie said, and that is the importance of data. And so when it comes to our adversary developing this, I'll tell you, I think about the cultural relationship of data in the Russian and the Chinese environments versus the United States and in the West. Now, I don't know exactly what the Chinese are doing and what the Russians are doing with data, but it seems like their government has a lot more control over data than what we might have in the West holistically. And so when I think about what the Russians and Chinese may be doing, they have what could be a lot more flexibility in controlling this data and allowing them to come up with artificial intelligence at a quicker rate because of their different holistic ways of looking at the control of data. I'll also tell you that I've been in military units for over 28 years, and military units, I mean, I'm even in an ISR unit right now. I'll just tell you that we're very good at executing the mission. When it comes to controlling and documenting and putting data in databases that can be searched and used for future reasons, we have a lot of room for improvement. I'll leave it at that. And then finally, I'll say, when it comes to the alliances, we have even more challenges. Being the commander of a NATO unit here has really opened my eyes at the challenges that we face when it comes to how Germany looks at the control of data, how the Dutch look at it, how the Brits, and then of course how we do, and then coming up with networks that are able to share that data becomes almost a bridge too far. So when I look at the future of AI, I first look at how do we get the data to inform the AI, and I think we have some significant challenges moving forward.
Okay, on the flip side, what are some potential opportunities for the U.S. and allies to leverage AI to their own advantage, particularly as we look to great power competition?
Yeah, we certainly have one fundamental advantage. And what I think that is that we in the West are unafraid to push decisions to the edge. And we're seeing this play out in Ukraine right now. In the Ukraine, we're hearing these stories about the Russians trying to bring all decisions back to some type of a headquarters, and they're really not empowering their personnel on the edge. And that's doctrinal for them. And, we always wondered how it would happen in real life. And we're seeing it play out right now in the Ukraine. And this is a tremendous learning opportunity for all of us in the West to see this actually unfold. So the fact that we are already comfortable with pushing decisions out to the edge, I think that gives us an advantage. Additionally, we also have some success. I know it's not an AI algorithm, but automation in itself is also a challenge. And the fact that we in the West have pushed very automated systems into warfare and into combat, I think is going to give us an advantage as we try to incorporate AI into some of these. You look at the RQ-4, you look at the RQ-170, these systems are highly automated. And I'll just tell you, even for someone, so I've commanded several unmanned aircraft system units, both MQ-9, MQ-1, RQ-170, and now RQ-4. And I will never forget the first time I sat at the end of the runway and I watched an RQ-4 come into land. I mean, the wingspan is that of a 737. And I just sat there in awe going, I cannot believe there is no human being directly on the controls of this huge aircraft, purely automated as it's going through landing. And as an operator, that was very uncomfortable. But we are continuing to mature as a force, and we are beginning to accept some of these automations, and we will soon move on to artificial intelligence, and that's going to give us an advantage over our adversaries.
Yeah, so Stacie, as we get closer to deploying this technology, how are those human-machine teams going to look, and what are the options for work sharing between the human and the machine?
Sure. That's a great question. And that's honestly, some of the stickiest, questions we have to dig into as we look to deploy this technology, especially when we start talking about human machine teams. Because like I mentioned before, as humans, we have, a finite amount of resources that we can devote. And, we're good at certain things and machines are good at certain things. And so as we start to kind of come up with the areas where we want to deploy this technology, we really need to start looking at how are we going to break down those tasks, right? So some things to consider is, humans, we can only focus on so many things at a time, right? So how are we going to, have the human kind of control a large number of different entities, right? If those entities get to the edge of what their capabilities are, how do we alert the human that that's happening, right? So we can't have, 5 or 10 different, alerts flashing at the human all at the same time, right? So how can we do things like prioritize them? How can we give the human context, right? When they're, kind of piggybacking off of that example before, if something went wrong with the automatic landing system, right? How do we give the human, the indication that, hey, it's your turn to take over control, right? As humans, we can't necessarily jump right back into the action without context, right? So we may have to have like certain queuing that lets you know that, hey, like in 5 to 10 seconds, I'm going to need you to hop back in and give them the information that they can do to do that safely, right? So all of these things that we need to start looking at and are, things that are going to be probably fairly mission centric and task specific. And that's why it's so important to have, the interdisciplinary teams work on these type of concepts, right? You're going to need your engineers, you're going to need your human factors professionals, and you're going to need your operators to understand, what the ultimate goal is of what we're trying to design.
General Cantwell, given your experience flying manned and unmanned aircraft, how do you envision the mix when it comes to manned and unmanned systems sharing the workload? What does AI need to do to reduce tasking rather than increase it for you as an operator?
Yeah, thanks, Slick. When I think about this challenge that we're going to be facing, I think less about making the unmanned system, the AI system, and the manned system, the non-AI system. And I think about what processes can be put on each platform. Because there may be AI processes, maybe defensive systems that can go on the manned platform that actually saves an air crew's life. But there may be things that go strictly on an unmanned system. So I think we need to focus on the processes and figure out which processes need to be automated. And once we figure that out, Then we work on the automation, and then maybe that moves to an AI algorithm to make it even more effective beyond automation. So in my experience with several automated systems, the RQ-4 Global Hawk, we could put automated software into the system that would keep the aircraft in a certain piece of airspace, avoid the adversary's airspace, handle emergencies, all in an automated fashion. We have the technology to do this. However, any of these processes costs a great deal of money, not only to develop it, to get the human-machine interface correct, but then in some cases, you have to go through an airworthiness process. And so you have to pick these processes very carefully, because in some cases, it may actually make sense just to keep the human in the loop, just to save the costs. And I think we're going to see many of those similar discussions going on when it comes to AI. 20 years from now, however long that is, there's going to be a lot of processes that we could put AI into the process, but we have to carefully think about what the costs will be associated with each of those processes. In some cases, the cost may not matter. Maybe the mission effectiveness is the absolute priority, and we believe that AI is going to be the way to maximize mission effectiveness. In that case, we're going to do what it takes to get the AI incorporated and get the maximum amount of mission effectiveness. But in other cases, it may make sense to have these difficult conversations. But I want to say one more thing, and that's about what Stacie just brought up about reducing workload, because we see that all the time in our automated systems. And this is going to be a continual challenge. We're seeing this in 5th generation fighters. We're seeing this in unmanned systems. When you reduce the workload so much from the operator, oftentimes the operator, it's scientifically proven. It's difficult for the human brain to be disengaged for hours at a time and then suddenly be asked to jump into a very complex situation after sitting at a computer console for several hours. So this is going to bring on a new challenge as we continue to bring more automated processes and maybe some processes that are controlled by AI algorithms.
Houston, can I tag in here? I think a lot of times people think of AI as this magical brain that's going to solve everything. And I think just because AI is a good tool doesn't divorce it from the systems that we have already, right? So I think a lot of people think it's going to be this magic pixie dust we can put on everything, but really it's going to fit as a system of systems inside things that we already have, right? And like you were saying, breaking it down by what do we want it to accomplish? Where's the value add for it? And then how do we actually integrate that into systems that we already have? Because just because AI is going to be this great tool doesn't mean it's going to reinvent the whole DoD, right? All of the systems. We need to be smart about where we want to deploy it. And I think a lot of that is lost sometimes in the buzz about how it's going to be this fundamentally changing technology.
So I've got to ask you this, because everything you've both mentioned so far is all well and good, but we actually need to be able to deploy this AI in operations. How well is the Air Force and industry actually positioned to develop, maintain, and further develop autonomous systems like the Air Force Skyborg program? And the question really is, how well can we do software compared to hardware?
Sure. So when it comes to, actually, like we were talking about operationalizing, AI ML, it really comes down to getting the infrastructure in place to actually productionize it, right? Like Houston was saying, a lot of times we're very good, at executing our missions. We know what we want to do, right? But sometimes I kind of like to joke and call it the plumbing, right? The plumbing to get us to where the data needs to be, to collect the data, to manage everything that we're trying to do with these systems just isn't there yet, right? So everybody kind of wants the flashy new algorithm to, get to the end state, but there's not always, that kind of unglamorous back end, if you will, that facilitates all of that, the shiny, mission capable stuff. And I think putting the work in to make sure that, we have a consistent, strategy for data collection, data mining, storing it, annotating it. That's all the stuff that happens in the background that's unglamorous, but is going to be extremely important towards, actually getting this stuff in the warfighter's hands and getting it as stable as it needs to be deployable.
Houston, any thoughts?
Yeah, this has been something I think about a lot in my current job, and I certainly think about as we look forward with AI. It's absolutely essential, but not only getting in early on the experimentation, but building an iterative process. You have to have an iterative process that is rapid, that goes between the engineers who know what the art of the possible is with the operators who go, oh, that would really help me solve this tactical problem. And it brings me back to a situation when I was a lieutenant flying F-16s. And I'll never forget, this engineer showed up in our squadron in the middle of Korea. And as a young fighter pilot, this engineer shows up with some options for the next radar tape. And that really left a memory in my head, because I thought, you know what? These engineers, they have no idea what the operators need. So here's this guy flying all the way to Korea to figure out what's going on. Now, that's the process back in the 90s. Sadly, I'm not convinced that we've improved that process tremendously between then and now. But we absolutely have to, because software updates are cost prohibitive, and we have to get this iteration between engineer to operator to go at a much faster rate. And I think we've actually heard the Chief of Staff of the Air Force talk about this challenge as we continue to move forward. Another challenge we'll see on the unmanned systems piece is when it comes to software, we've done a poor job of separating the flight software from the mission software. Oftentimes, they even go to the same central processing unit on the aircraft. This results in some significant airworthiness processes into this iterative process, slowing it down tremendously. So in the future, we have to deliberately separate as many of the flight processes from the mission processes, so that when we find better ways to do the mission software, we don't have to go through that very laborious process to make sure it's not going to affect the airworthiness of the aircraft.
All right, Stacie, turning back to you, Google once famously referred to its machine learning and AI efforts as, quote, a high interest credit card, because while the benefits of AI were often clear, preventing unexpected or harmful behavior in the automated systems over the long run was tougher, more difficult, and more costly than anticipated. So is this still a challenge today?
Yes. So I would say, in short, as we look to deploy these systems, as we look to, increase automation, those potential unintended consequences are always real, right? This is a very emerging area, and we're still kind of learning how to deploy this, right? And so I think those are very important questions that we need to be asking ourselves, because not only do we need to fight the technical side of the house, right? We also have the societal, human impact type of, considerations to take into account. One thing we need to be very careful is when we start asking these systems to do things, we need to make sure we determine what we expect of them, where we are comfortable deploying them, and then, like Houston was saying, where do we, push those decisions to the edge, right? And so I think that's an ongoing conversation that we have to have. And I think, as we, continue to figure this out, those lines will hopefully become, more clear and kind of flushed out.
Okay, and a follow-up on that, Google's answer was to embed the employees who operate its systems closely with the researchers who develop the AI. So I'm curious, is this a viable method for the military too?
Sure, that's a great question. So I think, having, people who are going to use the AI kind of embedded, one, in its development process, and two, in its deployment process is extremely important, right? I think we expect machines to play a larger role, right? But they are not going to be the decision-making authority, especially when it comes to things where we know decision-making processes might break down in terms of our data or in terms of, the model that we used. And so having that operator insight and pairing it with this, exciting new emerging technology is going to be very important, right? Because we always want to make sure that we're being safe and that we have, something that's going to perform as expected. And I think, pairing, that's why we talk a lot about human machine teaming, right? We want to let the AI do what it's good at, what it's designed to do, whether that's, make decisions quickly or, protect the operator in certain situations where they might not be paying attention, right? Then we also want to make sure, the operator has, the final say in some things that are, extremely important or could have, repercussions or ramifications. And I think that goes back down to, what Houston was saying, the engineers, we need to talk to the operators, right? This is going to happen. This development needs to happen in tandem, and we need to be, speaking to each other and, designing these systems in a way that, everyone, understands what they're doing and feels comfortable with their deployment.
Stacie, can I ask a quick follow-up question? How much is that happening now in DoD in terms of getting engineers and operators in the same room? Is it something that you've experienced personally, and in what form did that take?
Sure. That's a great question. And so I think in terms of, increasing interactions with, the customer, for us on the engineering side, I think the move towards the agile development process has really helped. I know it's kind of a buzzword, we hear around all the time, but just seeing these software systems as more as of an iterative approach has really helped people kind of, match their mental models. I kind of like to joke that, no matter what, these AI systems are going to kind of be pets, right? It's not like a system that you deploy and set it and forget. These systems take, care, feeding, and kind of, walking, if you will, right? Because we're going to need to monitor the data on them. We're going to need to, monitor their performance, because these things can drift over time. And so I think, as our policymakers start to understand that, I think they're going to, hopefully increase our chances to be able to interact with the operators, because they'll see what benefit, those interactions can have. And I know some of the, the best projects I've had the opportunity to work on, there's been a very close teaming between those two sides. And I think it only makes us better, because these problems are, so complex and so interdisciplinary.
Houston, if you could talk a little bit about the importance of building trust in AI. From your experience flying both manned and unmanned aircraft, it'd be interesting to hear how important you think that is, and some examples of what can happen when that trust isn't there, and why it's important to have in a warfighting context.
Thanks so much, Caitlin. First of all, I got to tell you, this is a recognized challenge across the spectrum, whether it's combat ops or non-combat ops. I remember my time as the vice superintendent at the Air Force Academy. They drive a Tesla up to my office and they go, "Hey, Vice Sup, hop in." I'm like, "Wow, where do we get this Tesla?" It's all painted up like Air Force Academy, and it was an absolutely beautiful car. And they're like, "Sir, we're using this to put people in it, and then we're rating how much trust they have in the automatic driving modes of the Tesla." And I go, never really thought that was an issue. But then when you're sitting in an auto driving car, it quickly becomes apparent that there are some significant challenges when it comes to whatever that logic is that the vehicle is doing automatically. And I certainly think that we see some of those challenges in aviation as well. I'll tell you, really the biggest challenge beyond the trust is making sure the operator fully understands the logic trees that the system is going to be going through, because the operator is ultimately responsible for the safe operation of that vehicle. And when we're dealing with automated processes, there are all these decision trees that are written out in the technical orders that if this happens, you can expect the system to then do A or B or C or whatever it is. And it becomes a significant challenge to understand all of the different branch plans that a fully automated system may do. Now, when we move into a fully AI system following AI algorithms, I think there could be additional challenges associated with fully understanding what that platform is going to do if we elect to use AI in the control algorithms of these vehicles. Given an AI algorithm, when the computer is coming up with its own decision, how do we bound that so that the humans can figure out what to expect from the machine? Is that something that's talked about by the engineers?
Yeah, no, that's a great question. So kind of what you're driving at is, verification and validation and explainability of decisions. And that, like I mentioned before, we fight the technical challenges of actually accomplishing, X, Y, Z, and then you fight this needs to be interacting with humans, and they need to be able to understand why the machine, push button, answer out, understand that whole black box process. And I think, what it comes down to a lot of times, we're having conversations in the engineering community about how do we accomplish that verification and validation for these somewhat, more non-deterministic systems, right? You don't necessarily have a logic tree that you can trace through, or, a systems engineering diagram that's as clear cut as we're used to, right? Because the reason why we sometimes use AI is because these decision-making processes don't lend themselves to being broken down in our traditional ways, right? And so as we start developing and deploying these systems, we need to determine what is our acceptable level of risk for these systems that are, harder to verify and validate. And I think, that added complexity needs to buy its way on the ship, so to speak, right? If we're going to be able to use that, that added complexity and challenge needs to be justified. And then you need to start looking at, okay, how do we, verify and validate that it's going to be performing as expected? And I think we're going to have to probably develop some new tools for that, and figure out, how we are going to test these systems, right? So we talk a lot about in the community, is a more software engineering, systems engineering approach good for these systems, or should we start viewing them more like we, verify human operators, right? So a lot of times, if you're a pilot, right, you'll be certified to, fly, just on nice, clear, sunny days because that's all we trust you with, right? But then with more training or more testing or more certification, you get certified with your instruments, right? So we may have the AI that we test in, limited situations where, we are letting it fly the plane on a nice sunny day, but then the pilot needs to take over, when it gets stormy because maybe we don't have the, instrumentation to do that, or maybe we haven't tested it there, right? And so designing those test plans and figuring out how we're going to do that is definitely a very open area, but one that I think is worth the time and the effort because of the added benefit that these systems can provide, right? We want to make sure that we don't necessarily get scared of deploying them just because the risk is there. Because, like Houston was mentioning, our adversaries are very much looking into this technology, right? And so it's something that's going to be challenging, but something that we definitely need to look into and, decide the path that we want to go down for that.
Awesome. Thanks for that. Now, we're running a little short on time, as we often do on the Aerospace Advantage, but I have one more question for the both of you. When you step back and think about it, what does the Air Force need to do to make sure that we get the most out of AI in the future? And what does it also need to do to make sure that it minimizes the risks?
Yeah, thanks, Slick. I'd offer two thoughts. First, most innovation books that I've picked up recently, they focus on simplicity and scale. Do something small, fail fast, but take your successes and then push those to drive change. I think we bring our operators and engineers together like we talked about, discuss what's the art of the possible given the technology that exists, and then define the requirements, determine what data is needed, and then let's iteratively start developing what these new AI applications can be. I think we got to start small. For those who think, there may be an engineer out there that thinks the NGAD, right? We're going to put all the AI algorithms into the NGAD and it's going to conquer the world. I'm not confident that that's going to be the path to success. I think we got to think small and then incorporate, as Stacie mentioned earlier, different pieces and parts onto existing systems. But secondly, I think the Air Force, we together holistically need to set the conditions. What I mean by that is set the conditions that's going to allow AI to flourish. I talked about one of them already, which is data sharing, streamlining data sharing within existing alliances, identifying what types of data might be important for future AI, and how should that data be structured so that we can then use it in the future. But additionally, here's something we haven't discussed much during our discussion, but we need to set the conditions for successful networked warfare. Because in a lot of cases, you're going to have a platform out there that doesn't have all the sensors that it needs. It's going to have to take information from off-board sensors, whether that's space-based, land-based, sea-based. But that sensor is going to need information. You're going to need real-time data to potentially use an AI algorithm to get a win on the battle space. We as the Air Force need to help set those conditions in the electromagnetic spectrum. You've heard the United States Air Force talk about the importance of EM spectrum because of, some would argue, we've lagged the fight for the past few years. and we have put a lot of resources into it. They stood up a new EM spectrum wing, and then now we've got an office at the Pentagon led by a general officer working on electromagnetic spectrum. But having these experts and ensuring EM spectrum superiority is going to enable, again, at the tactical edge, some of our AI platforms to get the data real time that it needs. Because if those data links are severed, now whatever that processor is with the severed data links would not be able to make an informed decision, and thus putting us at a disadvantage.
Stacie, your thoughts?
Sure, thanks, Slick. So for me, I think it comes down to kind of 3 I's, right? We need the infrastructure. The infrastructure to collect and manage the data is definitely a challenge right now. We also need to make sure we focus on the fact that the people that are going to be building this, it needs to be interdisciplinary teams, right? We need the operators, we need the engineers, and we need the human factors focused people because these problems are very big. They touch on a lot of different pieces and different moving parts. And I think to make sure all those disciplines are represented there, we're just going to get systems that are more complete and more capable for the warfighter. And then, like Houston was saying, we need the ability to iterate, right? A lot of times, we're used to, defining requirements, marching down, delivering something. Unfortunately, just the nature of these problems and, the nature of the data that we have available or the tools that we have available to us, you're going to learn things on the process, right? We can't always necessarily know everything at the start. And so, being able to empower these teams, getting the right people on the teams, and then, building things out with what and then kind of, building some slack in to learn some things as you go about developing this technology in the process to make sure at the end it's what we need and what we want is very important. And, that iteration, like I said, is impossible without having the infrastructure that you need and the interdisciplinary teams to solve the problems.
Well, a huge thanks to both of you for this fascinating conversation. It's really clear that we've got a lot more to cover on this, and it really counts. And we know China sees AI as a path to offset conventional U.S. military advantages, and Secretary Kendall clearly intends to do something about it.
Thanks, Slick.
Thanks, Slick.
Thanks, Slick.
With that, I'd like to extend a big thank you to our guests for joining in today's discussion. I'd also like to extend a big thank you to our listeners for your continued support and for tuning in to today's show. If you like what you've heard today, don't forget to hit that like button and follow or subscribe to the Aerospace Advantage. You can also leave a comment to let us know what you think about our show or areas you think we should explore further. As always, you can join in on the conversation by following the Mitchell Institute on Twitter, Instagram, Facebook, or LinkedIn, and you can always find us at mitchellaerospacepower.org. Thanks again for joining us, and we'll see you next time. Stay safe and check 6.